Okay, so this is going to be an intro topic to like basic statistics. DJ, what was the symbol that was the population standard deviation? Do you remember from yesterday on the calculator? What was that? What did it look like? Yeah, sideways T looking thing. Good job. Does anybody remember what that mean or average was?
The X bar.
Good. X bar, nice, was the average or the mean. What was the sample standard deviation? Good. Awesome. Nice. Okay. So yesterday you guys kind of learned how to get the average, how to get the standard deviations on your calculator. Today what we're going to look at is something called normal distribution and kind of how statistics is used. All right. Has anybody ever heard of a bell curve?
Yeah.
Maybe like if something's graded on a bell curve, what it means is they kind of make the scores fall into like this curve model. And in this curved model, where are the majority of the scores? What do you guys think? Where do they fall? In the middle. Good. Okay. So see how this part in the middle is where the majority is, like the highest percentages, it's the top things, there's the most in here. Okay. Think about a class. When you guys give a test, don't you want most of the kids to be like, you know, passing and doing pretty good? Right? There might be a couple kids who score really high, right? Maybe a couple kids who fail, but you want the majority to be like, you know, passing with a good score, right? That's something called grading on a bell curve. And a couple things in this bell curve, when your data is modeled like this, the mean and the median are going to be actually the same thing in normal distribution. And we're going to put the mean all the time in the middle. So X bar is always going to go in the top part, all the time. It's directly in the middle. Now, if you guys split this down the middle, 50% of the data is on the left and 50% is on the right. What we're going to work on today is moving on the curve. And the standard deviation, let's see, on the bottom, right? See how you have like -1 and +1, the -2 and +2. That represents how many standard deviations you are away from the mean or away from the average. I think we used CJ and Nick Dame one day about their test scores, like how far their scores were away from the mean. Yeah. So what these scores down here are going to show you are how far you are away from the mean, and that's going to represent your standard deviation. In our curve, some of the things that are going to be really important that we're going to work with today, and you guys kind of want to know, memorize this stuff. 68.2% of your data is going to be one standard deviation away. So what that means is if you look between the -1 and the +1, and you added up all these scores between them, it's about 68%. The other one that's going to come up a lot for you guys is if you went 2 standard deviations away, right? Weigh it with the 2. So if you went to the +2 and the -2, and I added all these scores up, we'd be at about 95%. In here, we're not going to get super involved with like, you know, the top 2%. We're going to work more between 1 and 2 standard deviations. So this is the big stuff you guys are going to have to know. Now, to move along our curve, to actually see maybe what the scores would be here, what you guys are going to do to move across the curve is you're going to take your mean, and we're going to subtract the standard deviation, and then we're going to add the standard deviation. So that's going to be kind of what we're doing. Once we start doing some problems, you're going to see this is pretty easy. You're basically like adding and subtracting. Right? Yeah. I just have to do that. Rick, you guys have problems? Yeah.
All right. I got this.
Oh, thank you, Kylie. All right, so let's look at a couple of them. This is going to be how we're going to really be like using your scores here. So a set of test scores is distributed normally with a mean of 70 and a standard deviation of 6, between which 2 scores could 68% of the scores lie. So a couple things in here. When you guys are looking at something being normally distributed, they're talking about this like curve looking thing. And to show your work, you can make a little curve. And what we want to do is in the middle, Okay? The middle is always going to be your mean. So what do they tell you guys your mean is here?
70.
70. Awesome. You want to put that right in the middle. And they also tell you guys you have a standard deviation of 6. So we know the mean is 70. The standard deviation is going to be 6. All right. The big key in here to kind of tell you guys where to go, and this is going to be important for this class, 68%, right? How many standard deviations away do they say that is, 1 or 2? 68.2%, yep. But is it like 1 standard deviation away or 2? 1, good, okay. So 68.2% or about 68% is always 1 standard deviation away. What that means is on your curve, you want to get to the +1 and the -1. You want to get to these parts. Now to do that, all we're going to do is take the mean, and to get to the +1, we're going to add the standard deviation. So what was your standard deviation? Any ideas? 6, good. Okay, so we add 6.
Wait, so no matter where you are, like no matter what your numbers are, it's always 68.
If you're between like the 1 and -1, yes, it's always 68. And if you're between the -2 and +2, it's always like 95. Right? So you're going to see those numbers come up quite a bit. They're pretty important. So if you guys took 70 and you add 6, what do you get? 76. Awesome. Now, 1 standard deviation, you do need to go to the +1 and to the -1. So to go to the left, what we're going to do is subtract it. So let's take 70 minus 6. Yep, 64? Perfect. So the test scores in this set of data, right, where the majority of them will lie, where 68% of the scores are going to be, is going to be between the interval of 64 and 76. And that's it. That's like your answer. So basically, you're going to be taking the mean, adding the standard deviation, taking the mean, subtracting the standard deviation. It's like kind of how you show your work. Yeah, perfect, guys. All right, so let's read the next one. A set of voice heights is distributed normally. Okay, so we're dealing with our little curve looking thing here. Okay. The mean is 58 inches and the standard deviation is 2 inches. All right, where do we want to put the 58? In the middle. Awesome. The mean, okay, is always going to be right in the middle. Okay. And it tells us our standard deviation is 2. Okay. So mean is going to go in the middle. Right. Express in inches between which two heights 95% should fall. So let's look at 95% is going to be kind of our helpful hint here. 95% is that 1 or 2? 2, good. So if it's 2 standard deviations, that means we should have a little bit more work, right? We want to go all the way to the +2, and then we need to go to the -2. But the idea is still going to be the same. You just have to do it more than 1 time. So when it was 1 standard deviation, you just took the mean and added the standard deviation just once. Okay? But when you're doing it to the 2 standard deviations, do it twice. Perfect, Joss, you got it. Right, so let's add 2. What would you guys get if you added 2? 60. Good. Now we have to add 2 again. What would that give you guys? 62. Okay. So 62 is going to be way up here. To move to the left side, all we're going to do is subtract. So 58 minus 2 is going to give us, perfect, minus another 2, 54. Awesome. So with the 2 standard deviations, our interval is going to be 54 to 62. Sorry, it's a bad looking too. How are you guys doing like moving? Do you kind of get the idea?
I thought that the standard deviation was just how much you average subtract by.
It is. Because didn't you average subtract by 2?
So then, why do you have to do it twice?
The reason why you have to do it twice on this one, good question, Mitch. Right? If they say anything about with 95% of the data, or you want to go 2 standard deviations away from your mean, 95%. It's like a key word that you're 2 standard deviations away. So that's why you're doing it like twice. if it says 68%, like this one, 68% means you're one standard deviation away, that's why you want to
So
do
it
one.
depends on the percentage.
Yes, good. Or if it says like in the problem, like what intervals are one standard deviation away or what intervals are two. That's kind of like your clue.
Okay.
Right? Okay, let's try this one. So here we're talking about drinking soda habits. Make sure you guys are kind of reading carefully. They tell us that they reveal the mean number of cans of soda consumed per person to be 20. Holy cow. A lot of soda. Per week. Holy cow.
20 cans of soda a week? That's like a lot of
Maybe
days.
it's like a good 3 cans.
Yeah, holy cow, they're gonna get bad. Diabetes. Jeez. Alright, so the mean is 20. Okay, standard deviation they tell you is 3.5. Okay. If you're normally distributed, find an interval that the total number of cans is 95%. Okay. 95%. What how many do we have to go? One or two? Two. Perfect. Okay, good. So let's make our little picture quick. Alright. Make sure you guys put the mean right in that middle part. What are you gonna add?
3.5.
3.5. Good. Yeah, what do you think is the first part? 3.5. Good, so you got 23.5. Love it. Good, if you add it again, 27.5. Awesome. And remember, you wanted to go to the two. Just 27? Oh yeah, 25.5. Good job. Okay, then we gotta subtract it. Next, you want the subtraction?
60.5.
Good. 16.5. You got 13?
Yeah.
Super. So make sure at the end, if you just want the 95%, just take the interval at the end part, like the 2 away. So 13 to 27. How's that looking? Good and bad? The interval selected is because you're 2 standard deviations away, and that you knew that by the 95%. Okay. All right. So this one's a little bit different. Okay, just a little bit of the wording, but same kind of idea. So the mean is 50, they tell you guys, and the standard deviation is 4. What is the best approximation of the percentage of students who could be expected to score between 46 and 54? So these are the intervals. They give you guys the intervals this time. So it might be helpful to kind of see, well, how did you get to those numbers? Right? What would you put in the middle? 50, good. Okay, now we want to get to these numbers. So let's make our little chart. I don't know if I have to go to the +1 or the +2s. You think the +1s? What would you get if you took your mean and you added your standard deviation 1? Right, so we got 54 here. Is that what we needed? Oh, yeah.
Yeah, 46.
Nice job.
So it would be 2.
Okay, so if you guys only did it one time, what percentage are you do that? Yes, Sam, awesome, 68%. Good job. How do you guys feel about this stuff?
Good.
Not too bad? You like this part? And we're not going to get in,